All right, folks, here, let's talk about Newton's third law. All right, Newton's third law is the one that most people know the words for it. It's all about action reaction. Right? And the most common word is, common phrase is for every action, there's equal and opposite reaction. Right? So basically what that's saying is if I have a box here and I push the box with a force, that means the box pushes back at you with an equal force. That would be F here, but in the opposite direction. So in other words, if I were to, you can't quite see it, but if I'm on my sitting behind my desk, if I push on my desk with a force of 100 pounds, that means the desk is going to push back on me with 100 pounds, right? If you've ever stood on ice with a friend, you've felt this, because if you push them one way, they slide one way, but you slide the other, right? Because they apply that equal force in the opposite direction, right? So forces always come in pairs. For a force to occur, another one has to push back. Right, so a 550 Newton person is sitting in a chair. What force is the chair pushing back? 550 newtons upwards. Because you're pushing downwards on the chair is pushing upwards. You stub your toe on a wall with a force of 20 newtons. With what force does the wall hit back? 20 newtons. Opposite direction. You push a crate with a force of 70 newtons. With what force does the crate push back? 70 newtons. Okay, opposite direction, equal and opposite forces. Okay, the equal opposite forces cannot, if they cannot sustain, then it's going to break. Okay, so like if someone were to sit down on a chair and the chair had a broken leg, and if someone weighs 150 pounds, but that chair can't push back up with 150 pounds, something's going to break, and it breaks, and then that force isn't applied, and you fall, you accelerate downwards. Okay, great example is a bug on a windshield. Right, when the bug, the windshield applies a force to the bug, and the bug can't apply that same force back, and it goes squish. Right? Elevators, all that type of stuff. Right? So why do things move? Okay, the equal and opposite forces are only the forces. Right? And then Newton's second law comes in. If one object has a larger mass, they have less acceleration. Consider a baseball hitting a baseball bat. Right? They apply equal and opposite forces to one another, but the baseball accelerates a lot more than the bat does. That's because the baseball has less mass, has more acceleration. The baseball bat has more mass, and it has less acceleration. Right? So a Fiat, little tiny car, and an F-150, a big truck, crash head first. Which vehicle experiences the largest force? They both do. They experience the same force. Which experiences a larger acceleration? That would be the Fiat, because it has less mass. Okay, so those are Newton's third law. And now with 3 videos, we've covered all 3 laws of motion. Right, at this point, I want you to practice some of the problems. Most of it is Newton's second law problems. And then after we go through this week, we'll spend some more time going into specific types of forces. We'll look at vertical forces and horizontal forces. All right, be sure to check the announcements about the optional midterm that we're going to have when we come back from fall break. That'll give you an opportunity to replace any grade that you want that's in the grade book right now. Probably a test, but if you all have done well on all your tests, you could do something else as well. All right. If you all have any questions at all about this, what's said here, or other questions, I'll have my Zoom open Monday and Tuesday for you to ask questions. So please come on and ask. Thank you.